so much for being a part of my journey. So, I have started to read this book, Writing the Coding Interview. So, I would be reading it and explaining it as much as I understand. So, let's get to the page where we have started to solve the problems. What good coding looks like. I was reading how to write good code, modular code, and why is it important to write modular code. And it says, don't give up. This is our motivation for today. One no interview question can be overwhelming, but that's the part of where the interviewer is testing. Do you rise to a challenge or do you shrink back in fear? And then no and nothing can make me shrink back in fear. The offer and beyond. I don't have an offer, so let's not talk about it or read about it. Interview questions. Finally. So this also says join us at this to download the complete solutions, contribute or review solutions in other programming languages, discuss problem from this book with the other reader, ask questions. Let's try again the open link in a new tab. I was studying about RAG from Piyush Garg's video and it was really wonderful. Related searches, top 10 interview questions. What is, um, do I need to add www in it? Well, forget it for now. Okay. Hopefully all readers are good familiar with arrays and strings, so we don't bore you with such details instead. So we already know what are a hash table. It's a data structure with maps keys to values for highly efficient lookup. There are numbers of ways of implementing this. Here we will describe a simple but common implementation. In this simple implementation, we use an array of linked list and a hash node function to insert a key which might be a string or essentially any other data type and value. We do the following. First, compute the key's hash code, which will usually be an int or long. Note that two different keys could have the same hash code, as there may be an infinite number of keys and a finite number of ints. Then map the hash code to an index in the array. This could be done with something like hash key %length. Two different hash codes could, of course, map to the same index. Okay, I basically do it in C++, so for me it's pretty different. At this index, there is a linked list of keys and values. Store the key and value in this index. We must use a linked list because of collisions. You could have two different keys with the same hash code or two different hash codes that map to the same index. But wasn't it supposed to be a hash map with a dictionary? Basically anything that maps a data structure with keys and values for highly efficient lookup is called a hash table. Just like dictionaries in Python, there are a number of ways of implementing this. Okay, these are the different implementation. We can use an array of linked list and a hash code function. Okay, first compute the key's hash code, which is usually int or long. Let's say if it's high, this is going to be its hash code with an ABC 980 and then we can link it like this. Doesn't it look like how the tokens and vectors work in vectorization when we are training an LLM? We will discuss about LLMs some other day when I'm not worried about getting a job. At this index, there is a linked list of keys and values. Store the key and value in this index. We must use a linked list because of collisions. You could have two different keys with the same hash code, okay, or two different hash codes that map to the same index. For index 0, we have two different hash codes, and both our different hash codes has two different values. Alternatively, we can implement the hash table with a balanced binary search tree. This gives us a 0 login lookup time, O of login. Why is it written 0? It should be O of login lookup time. By the way, login lookup time is also, we can achieve this using binary search in a sorted array. By login times, we mean that let's just open XKLE draw. How do we actually achieve the login time? Let's say we have a huge array. We will divide it and check if our value is at this or this. If it's on this end, then we'll divide this and then check it on this end. Then divide this. If it's on this end, then we'll check this, and somehow we'll end up isolating one of our values which we need. That's how we get a login lookup time. Login lookup time basically, if you have known of a tree data structure which has roots, how the binary tree works, and why is it easy to search in a binary tree, it's the same. Let's say our value is at this. So we are traversing it once, twice, and this here we already get our value. So one search, two search, and three searches. We got our value in just three searches. We don't traverse the whole tree as if we need it. Okay, let's get back to it. Array UST and resizable arrays. This book is for those who do DSA in Java, though I do it in C++ and C++. These resizable arrays are called vectors. In some languages, arrays, often called lists in this case, are automatically resizable like vectors in C++. The array or list will grow as you append items. In other languages like Java, arrays are fixed length. The size is defined when you create the array. When you need an array-like data structure that offers dynamic resizing, you would usually use an array list. An array list array that resizes itself, of course, while providing 0 and access. What 0? O1 access. Where is O1 access? Oh, access time. Okay. A typical implementation is that when array is full, the array doubles in size. Each doubling takes O(n) of time, but happens so rarely that its amortized insertion time is still O(1). Alright, this is an essential data structure for interviews. Be sure you're comfortable with dynamically resizes array in whichever language you're working with. Why is the amortized insertion runtime O(1)? Okay, let's check what is amortized. Meaning initial cost, reduce or a payoff. Bro, why use such heavy English words? Insertion runtime is O(1). Suppose you have an array of size n. We can run backwards to compute how many elements we copied at each capacity increase. Observe that when we increase the array to k elements, the array was previously half that size. Therefore, we needed to copy 6 elements. Final capacity increase n upon 2 elements to copy. Previous capacity increase n upon 4 elements to copy. Therefore, the total number of copies to insert n elements is roughly, which is just less than n. As the sum of the series isn't obvious to you, imagine this. Suppose you have a kilometer long walk to the store. You walk 0.5 kilometers, 2.1, then 1. You'll never exceed 1 kilometer. Yeah, of course, that's right. If you have an array of size n, you can work backwards to compute how many elements you copy with each capacity increase. Okay, so it's telling us how the capacity of a resizable array increases. Therefore, inserting n, why is it always less than O(n)? And why is each insertion is O(1) on average, even though some insertions take O(n) time in the worst case? Next up, we have a string builder. Imagine you were concatenating the list of strings as shown below. What would the running time of this code be? For simplicity, assume that the strings are all same length. Oh, there has to be some same in C++, a string builder equivalent in CPP. We are doing it. I just prefer to search right away because I forget what kind of doubts do I get as my bad memory forget and excuse my ADHD habits. C++ equivalent of a string builder is a string buffer or string builder. Pro I still use this Stack Overflow. Mhm. Strings are mutable exactly. The entire reason a string builder exists is to cover inefficiency of Java's. This is string builder. Okay, so you should be glad we don't need such a class in C++. So in C++, we don't have anything like that. All right, this is much better. I liked it. On each concatenation, a new copy of a string is created, and the two strings are copied over character by character. The first iteration requires us to copy X characters. This is a code for joining words. How does it happen in C++? We'll be solving problems anyways, so for the time being, let's just go through the book. The total time therefore is O of x plus 2x plus nx. This reduces it to xn squared. String builder can help you avoid the problem. String builder simply creates a resizable array of all the strings, copying them back to a string only when necessary. I don't need Java. This is unique. Implement an algorithm to determine if a string has all unique characters. What if you cannot use additional data structures? Okay, let's solve the first problem. Let's open Gemini or wait, Chat GPT to check if there is a question which exists like this. I have two viewers right now. Wow. One is myself. Who is the other one? The classic problem cracking that doesn't exist as an exact one-to-one problem, but there are very close equivalents that we can practice. Some idea, but for arrays instead of teachers using hash sets for uniqueness. Okay, pretty much similar, but given an integer array nums, return true if any value appears at least twice in the array, and return false if every element is distinct. For this, we can just use hash map and return true or false if, or maybe we can use a hash set, put all the values in the hash set, and return the size of set and array is not equal. Let's try it. Mm, I think we can fill all the values from here. Should work. Mm, let's see. Uh, if it's same size, then true. Okay. Now it's correct. Well, that was pretty fast. Let me reset the timer. But our goal is to check if we can do it without using any additional data structure. How can we solve it in O1 space? If any element appears twice, how can we do it? Hmm. Let's check the array anagram problem. This is already solved. How can we do it without using extra space? That was our main motive. This is pretty much like valid anagram, which we have already solved. Mm. If I could solve it, but that would be in O n squared. I can definitely solve it. This should also work, but that will take O n squared time. Okay, why is it returning this? Because we have to skip the case where I and j are equal because they are pointing to the same array. So there would always be a time when it will check the same value. Mhm. I hope it doesn't give time limit exceeded. Yeah, time limit exceeded. I knew it. Sorting, no extra space, and it will do it in log in time. You cannot modify the array, then it's brute force. Okay, so there are three possible best solutions, and I've already figured out two of them. I just needed to figure out the last one. Hmm. Let's try the third approach as well. Let's see if the third approach is going to work. Hmm. Oops. What am I even doing at this point? Alright, this is also done. So we have tried three possible solutions and three possible approaches. The best one was using a hash set. Let's solve it again. Seriously, this one took less time than the previous one. The previous one was taking 28 ms. But this was supposed to be an oven solution. Anyways, let's stop this one. Alright, this one is done. Then we have check permutation given two strings. Write a method to decide if one is a permutation of the other. Pretty much like if it's a valid anagram or not. Let's ask ChatGPT. Hmm. And this was first unique character in the string. Focuses on character uniqueness. Let's try this one also. Valid anagram is already solved. We have taken both of them into hash sets, and if the hashes are equal, we are returning true. We're not going to solve it again. This one is the first unique character in a string. Given a string, find the first non-repeating character in it and return its index. If it does not exist, then return -1. All right, let's start a timer. First unique character in a string. A string S first find the first non-repeating character in it and returns its index. So what we can do, we can make a hash set. It should work. I guess I should be able to solve such problems in less than 2 minutes. Well, another problem. This is my personal best record of solving a problem in 1 minute 35 seconds. I have done two problems so far. Great job. And let's try to solve it by the previous approach. This was the most optimal one with O(n) space and O(n) time complexity. We are going to solve it now with the n log n after solving it, after sorting it. So let's try. Let's see if strings can be sorted in C++ or not. Mhm. Let's see if it can be sorted. Mhm. Mm. Gulab jamun. Let's see if this would work. Nah, this would not work. It should not be equal to the previous one either. Mhm. Let's see. Oops. First, we have to check this condition. Mhm. We forgot to mention the case where the first one, oops, when we sort it. How are strings sorted? Okay, we'll mark it and we'll check it again for now. Contains duplicate. Implement algorithm to determine if a string has all unique characters. What if we cannot use additional data structures? We already done this one. This 1.1 contains duplicate, valid anagram. Focus on character uniqueness patterns. We'll check this one. This valid anagram. Okay, we have already solved it. Permutation and anagram. Group anagrams. Let's keep it to solve this later. Where is my Notion doc? There should be a Notion doc in which I write all the solutions. Karan's algorithm, container with most water, hash tables, valid anagram, intersection of two arrays, ransom note. Well, I have solved quite a lot of problems. Let's go to hash table and add that. What was the problem? Contains duplicate. These are some problems which I don't even want to mention that I solved because it was not that impressive. LeetCode 217 contains duplicate. Because bro, this is just, I'm trying to fill the pages. Where is that code? I have already solved valid anagram. There should be two approaches written on it. Ah, I forgot to write the approach. First unique character in a string. Hmm. Let's check what is wrong with this. Let's dry run it to check. If it is sorting, then E should be written first. 4 E's. E. No, D should be written first. Here also the first unique character that appears is the smallest character, which is D. Oh, if I sort them, then the indexes would change. Damn. How could I miss it? So there is only one possible approach to solve it. That is the one that I used. Do I have this time taken also? 1 minute 35 seconds. Sometimes, damn. Let's check the code. Oh, okay. This is accepted. Let's see the code. Valid anagrams. What was it? This was the first. What is the problem number? 49. No, this is already solved. Group anagrams. Now I need to solve this too. Okay. This one I have solved contains duplicate. Done. First unique character. But I think this is great if I write it like this. Yeah. Let's write down the problem. This is also done now. This should also have been in the part of strings. But I had done only one problem in strings, which was Roman to integer. It was also an interesting problem. How did I solve it? I think I should write this in the string also, this hash map problem. Was this also strings? I need to copy this whole. Forget it. Nah, this is not going to work. Forget it. I'll add it later on when I am in the mood to arrange the problems. Let's try group anagrams. So given an array of integers or strings, group the anagrams together. You can return the answer in any order. Anagrams, that means all those which are same. Uh, Would I need to make one hash corresponding to each of the values which I'm going through? Hash table array string sorting. Can these be sorted also? These can be sorted. And all those with same values would be arranged together. And two strings won't be equal. I will have to make a hash of all the values inside. I have solved this kind of problem before. Let's reset the stopwatch. Alright. How did I solve it last time? This is an anagrams. This is a 8 and TR anagrams. They're same. 8 is also an anagram. 8T8. Bat, Nat, 10. These are not anagrams. Oh, bat is an anagram. We have to make an array of same anagrams. I solved it before. One thing that I have learned in life that you don't have to spend hours and hours wondering if you can solve it or not. You can just look at the approach and code it out later by yourself. Well, this is a great idea, pretty much of what I was thinking. This is pretty much a long time complexity. This one is actually pretty difficult. Hmm. Oh, there are so many problems. This has to be something related to dynamic programming. Index of the first occurrence in a string. This is also seems easy, but let's do this one first. We made a frequency array. I really think the sorted one idea was a good idea. Thinking, but how are we going to use this as the key? Coding it out is going to be a little hard. Let's try.
Mm-hmm.
But how would we make a different array for each one? Its key should be a vector. Vector can't be a key. A single key can hold multiple values.
Mm-hmm.
I know the approach now, I just can't code the approach. Give me a minute. स्टेज तक। And I'm back. क्या लेना है? ठीक। It is going to store so many strings. This data structure, so much data, we are storing so much data. There is something wrong with this solution which I can't figure out. How do I push hash? What are we even pushing? He cheer. Oh, this.
Mhm.
नहीं. क्यों? आई होगी. All right. I don't know what's the complexity of this problem, but this seems to have taken quite a lot of space. It's taking so much memory. Reads only 15.8%. I don't even think that it's the optimized solution. Well, pretty much what I did, but this mine is much better than this. I'm using more space. I'm using same space, but I'm not sorting them. Then what do we do? This was actually a complex question. How this works. Two are done. Let's do this one. Just give me a minute, I'll be back. And I am back. But on LeetCode, there isn't a one and an exact problem with the true length constraint. There, the closest LeetCode equivalence you should practice. Replace all spaces with %20. There is no reverse words in a string. These are not opening any problems.
Oh,
This is not a LeetCode problem. Adding spaces to a string. Rearrange the spaces between words. You are given each word consists of one or more lowercase English letters and are separated by at least one space. It's guaranteed that the text contains at least one word. Rearrange the space so that there is an equal number of spaces between every pair of adjacent words and the number is maximized. If you cannot redistribute all the spaces equally, place the extra spaces at the end, meaning the returned strings should be the same length as text. This seems like a binary search problem. Just like how we place the aggressive vowel. Left, 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 left. And the extra spaces go to the end. First, we will count the spaces. I count the total spaces. Then I append the letters. I have formed a basic approach in my head, but how can I code it? I wanted to do all these 7 problems, not 7, but 9 problems today. I have already done this one, but without spaces. I have never done this problem without spaces. I did this yesterday, and I have to do this today. String rotation. If I finish this today, then I'll start with linked lists. Move right, could remove duplicates from an unsorted. How the sources the temporary buffer is not allowed. Return kth to last, emptying them algorithm to find the kth to the last element of a single linked list. First we'll go to the end. No, we can count the total and subtract the k from it, and then we can return the node, because there is no way to go backwards in a single linked list. Deleting middle node. If we were to delete a node that is in the middle, not necessarily the exact, given only access to. Now this is to be solved by the tortoise and hare algorithm, where one moves 2 steps and the other moves 1 step, and when they are at equal, partition right, go to a partition of linked list around a value x such that all nodes less than x come before partition a linked list around the value x such that all nodes less than x come before all nodes greater than or equal to x. If x is contained within the list, value of x only needs to be after the elements less than x. It does not appear that it means, is it sorted? If it is sorted, then we can do it. This is the input, this is the output. Hmm. Uh, this one is a good question. In list, you have 2 numbers represented by a linked list, where each node contains a single digit. The digits are sorted in reverse order, such that the v digit is at the end of the list. Write a function that adds the 2 numbers and returns the sum as a linked list. Add the numbers. This problem is on LeetCode, exact same problem. Implement a function to check if a linked list is a palindrome. If it's a simply linked list, I think what we can do, we can find the middle of the linked list and we can reverse the other half and then check if both the halves are equal. Combine the two lists intersect if Return the intersecting node. Note that the intersection is defined based on reference, not value. This is if the kth node at the first linked list is the exact same node by reference as the jth node of the second linked list. We can store all the nodes in a hash map. This is also a popular problem, intersection of linked list. Loop detection, and this is also a very popular problem. A corrupt linked list in which the node's next pointer that has to make a loop in the linked list. There are 8 problems in linked list and 9 problems in strings. 8 and 9 are total 17 problems. So if I study with all my strength today, I might be able to do the 17 problems out of 189 total problems which this book talks about. Alright, I ran out of the strength. I'll take a half an hour break and then come back because I have long lost the ability to work this long in one sitting. I'll see you after an hour or half an hour. Depends on how long am I going to